Hi class, this is course 3, lesson 34, proportions and ratio word problems. A proportion is a statement that two ratios are equal. And ratios, remember, are just fractions that compare. Okay, we're comparing two amounts using a fraction. And two different ways that we can see if they are equal. If you can see that you can multiply by the same number left to right or divide by the same number, similar to making equivalent fractions, that's one way to see if you have a proportion, if you can multiply or divide. Similarly, we could have divided by 2 and went backwards. If that number right here is the same, then we have a proportion. We can also look at it like the fractions down below here to see if it's a proportion. We can take 2 multiplied down times 3, and that's 6, and 5 to 15, that would multiply down and you get 3. As long as these numbers are the same, then you have a proportion as well. Now, the other way that you can look at this, and I know you know how to do this, the book isn't at that point yet, but if your cross products are equal, product, remember, means to multiply. If they're equal, then you have a proportion as well. Okay, so there are 3 different ways that you can look at your ratios to see if you have a proportional relationship. Okay, so we can use that knowledge to test for a proportional relationship, because just because they show us fractions that are equal to each other doesn't mean they're proportional. Sometimes we're using the equal sign for a different reason other than a proportion. So here's a fraction equal to another fraction, and we're just checking to see is it a proportional relationship. Okay, it might not be a true statement at all. So we can look at this and say, well, 2 times 5 equals 10. Does 6 times 5 equal 30? Oh, sorry, it does equal 30. Does it equal 28? Question mark. And so no, that doesn't work, right? You could also look at it with the vertical method, is 2 times 3 would be 6. Does that work this way? Can I multiply times 3 to get 28? No. So no matter what I do, this is not a proportional relationship. Okay. Not proportional. Down below we have a story problem here. Fred is paid $10 per hour. Is his pay proportional to the number of hours that he works? And so we can make a table. So if he works 1 hour, he would make $10, and his pay per hour would be the ratio 10 to 1. If he works 2 hours, he would get twice as much, right? $20, and his pay would be 20 over 2, which would equal 10 to 1. We can simplify that. Let's say he works 5 hours, he'd make $50, and that would be 50 over 5, which we can simplify to 10 to 1. Now, if we didn't simplify these, the way that we can test this is to take any 2. So maybe we'll take the 20 to 2 and the 50 to 5. Are they equal? Well, it doesn't make a whole lot of sense for me to try to multiply by something by 2 to get 5, or 20 to get 50. That's difficult. But I do know that if I go vertically here, I can divide by 10. Can I do the same thing here? Yep, I divide by 10. So this is proportional. So I would say yes, it is proportional. The rates will simplify to the same every time, or they will have the same relationship. They're proportional. Another example, Mary has houses to clean. If she cleans houses alone, it takes her 60 minutes. She's really fast, or she's not doing a very good job. But if one friend helps, it will take 30 minutes, and if two friends help, it will take 20 minutes. Is the amount of time proportional to the number of workers? So again, we'll make a table. So if one person is working, so that's just Mary, it takes her 60 minutes, and that would be 60 minutes for one person. If two people do the job, so Mary and her friend, it takes 30 minutes, which is 30 minutes for two people. And if three people work, then it takes 20 minutes, which is 20 divided by 3. Now, if you simplify, especially this one in the middle here, you get 15 for 1. Now, I can tell you that this is not proportional because 60 over 1 is not the same thing as 15 over 1. I know that. I can see that. So this is no, it's not proportional. You could also take any two of these and say 30 over 2, does that equal, question mark, 20 over 3? Any of the methods that you do, you could see that you would divide this by 15 if you go this way, and 20 divided by 15 is not going to get you 3, so that doesn't work. So that's how you can use tables and setting ratios equal to each other to see if you have a proportional relationship. Now for ratio word problems, you're going to use a ratio box, or that's one way to at least set up the correct numbers and correct labels in the right spot. So the teacher to student ratio, so I'm going to stop there and I'm going to write that down right away. Teacher to would be the fraction bar, student. Okay, so there's my labels, and I'm going to get a ratio box, and I'm going to have ratio, and I'm going to have actual. The teacher to student ratio in the primary grades is 1 to 20. If there are 100 students in the primary grades, that's actual students in school, so there would be 100. How many teachers are there? And that's where you put your variable. These are two fractions. It ends up being 1 out of 20 has to equal x out of 100. And so you can do any of the methods that I've illustrated. You could look at this and say, well, it's times 20, so whatever I have up here times 20 has to equal 100. Or you could say, let's see, I could multiply this times 5 to get 100, so I could do times 5 to get this number. Or you could do the cross products, 100 times 1, and then divide by 20. Either way, I hope that you can see that x has to equal 5, so there has to be 5 teachers. Okay, I don't think that this concept is particularly difficult, other than making sure that you use two different ratios to check to see if you have a proportional relationship. If you do have questions, please let me know. I'll see you.